All right, so let's take a look at this proof here. We've dealt with a couple of different types of proofs. We've talked about um, two-column proofs, and we also talked about paragraph proofs. Because so these are the two formats we've seen so far. Right now, we're going to talk about flow proof. Okay, a flow proof starts either from the top or from the left, and it moves right or down. Okay, and it has um, arrows connecting each box. Okay, and the justification for each step is written below the box. Okay, so below the statement. Okay, so let's take a look at this example right here. Here we're talking about proving that vertical angles are congruent, okay, the vertical angles um, theorem. And let's take a look at the proof. We start with a given statement that angle 1 and angle 3 are vertical angles, and we want to prove that they are congruent, okay, that angle 1 is congruent to angle 3, okay. Um, we start right here on the left. We start with a given statement that angle 1 and angle 3 are vertical angles. From there, we go up and down, okay, to two different statements. We're saying here that angle 1 and angle 2 are a linear pair. So if we look at our image, we have angle 1 and angle 2, okay? This forms a linear pair, okay? So these two angles right here, they form a linear pair, okay? Um, Angle 1 and angle 2 are supplementary. And the reason for that is their linear pair theorem, okay? Tells us that two angles are supplementary if they form a linear pair. Then the measure of angle 1 plus the measure of angle 2 is 180 degrees. And that's the definition of supplementary angles, okay? So if two angles form a linear pair, that means they're supplementary. And if they're supplementary, that means their measure adds to 180, okay? Now, before we move forward on this side, let's take a look at what happens down here. Down here, we're saying that angle 2 and angle 3 are a linear pair. So now 2 and 3 right here, okay, they also form a linear pair. Again, angle 2 and angle 3 are supplementary. That's the linear pair theorem. The measure of angle 2 plus the measure of angle 3 is equal to 180, and that's the definition of supplementary angles. So now, both of these statements that we just talked about, they are going to point to this box right here, okay? Measure of angle 1 plus the measure of angle 2, okay, which is right here at the top, is equal to the measure of angle 2 plus the measure of angle 3, and that comes from right here, okay? And remember, that is true because of the transitive property, right? Transitive property of equality. So I have angle 1 and angle 2 right here. Um, that's this one right here, and they are equal to 180, right? Then we have angle 2 and angle 3 here. When we add them together, we get 180. Okay, so that's this part right here, right? So if they're both equal to 180, then that means they're equal to each other. Okay, and that's the statement right here. Now, we use the subtraction property of equality, right, to eliminate angle 2 from both sides. And then we end up with measure of angle 1 is equal to the measure of angle 3. Okay, so that was the subtraction property of equality. And then angle 1 is congruent to angle 3. That's a definition of congruency. Okay, and that's the end of our proof because we went back to what we were trying to prove right here. Angle 1 is congruent to angle 3. That's always our final statement. Let's take a look at some examples and non-examples of adjacent angles, okay? So adjacent angles, remember, they're side by side and they share a ray. Notice that these examples, they all share the ray right here, right? They share this ray, they share this ray, and they share this ray, okay? So those are adjacent angles, okay? Now notice that on the non-examples, they don't share a ray. See, we have this angle of 100, and then we have this angle of 50. They don't share a ray, okay? This angle here of 35, and then this angle of 35, they do not share a ray. And then this one here, we have this angle here is 55, and then this angle is 45, and they do not share a ray, okay? So these are important, okay? Either they share a ray or they don't share a ray. So make sure that you're remembering that. Let's check some more examples of other angle pair combinations. So now we're looking at, okay, adjacent and supplementary, or adjacent and complementary, okay? They can be both, right? So in this first box here, we have a set of adjacent angles, right? These are adjacent, and they're also supplementary because they add to 180. 120 plus 60 would be 180. Okay, so these are adjacent and supplementary. On the second box here, these two angles, they're adjacent because they share a ray, and they're also complementary because 30 plus 60 is 90. They add up to 90, so they're complementary. Then on this third box here, we have two angles. Notice that they don't share a ray. They do not share a ray. So that means they're supplementary angles because they add to 180, but they're not adjacent. Okay. On this last example, we have two angles. Notice that they do not share a ray. So that means they're not adjacent, but they're complementary because 40 plus 50 is 90 degrees. So they're complementary angles, but they're not adjacent, okay? All right, so let's take a look at the first example, using vertical angles. Cross braces help keep the deck posts straight. Find the measure of each angle. So we're looking for angle 6, we're looking for angle 5, and angle 7, okay? So the measure of angle 6, okay, we can get the measure of angle 6 by looking at this angle right here. Notice the angle 6 and this angle, they're opposites. That means they're vertical angles. Remember, vertical angles are congruent. They have the same measurement, okay? So that means that because vertical angles are congruent, the measure of angle 6 is 146, okay? Now let's take a look at the measure of angle 5 and the measure of angle 7. So this is angle 5, and this is angle 7, okay? Notice that the two angles are also opposites, right? Which means they are vertical angles. And vertical angles are congruent. So the measure of angle 5 is going to be equal to the measurement of angle 7, okay? Now let's take a look and see if we can find the measurement now. If we look at angle 5 and angle 6, okay, these two angles, they form a linear pair, okay? And because they're a linear pair, that means that they are supplementary. Because they're supplementary, their measurements add to 180 degrees. Okay? So now I know that angle 6 is 146 degrees from the step above, right? So since the angle 6 is 146 degrees, angle 5 is just going to be 180 minus 146. Okay, 180 minus 146 will be the measure of angle 5, okay, which is 34. Now, because angle 5 and angle 7 are vertical angles, that means that angle 7 is also 34 degrees. And we're done. All right. So using supplementary and complementary angles, Example 2. Use the diagram below to find the missing angle measures. Explain your reasoning. Okay? So the first one we want to find is we want to find the measure of AFC and AFB. So AFC, okay, so I want to find this measurement right here. I want to make it in red, AFC. And I also want to find the measurement of AFB, AFB, okay, which is this one right here, okay, the blue one. So let's take a look at this picture. I know that BFC, okay, is 50 degrees, okay? I know that's 50 degrees. I also know that CFD, okay? I know that CFD is 90 degrees, okay? So this is 90 degrees, okay? This is 90 degrees, right? This part here is 50, okay? And then I know that this whole section right here, let me do it right here, this whole section right here, right, is a straight angle. That's 180 degrees, okay? So I have 90, I have 50, and then I need to figure out what this is. That's just going to be 180 minus this angle right here, 90 plus 50, okay? So when I have 90 plus 50, that's going to give me 140, okay? So this is 140. And that's this whole section right here, 140 right there. Now to get to 180, I need 40 more. Okay, so that's what this angle here is going to be. Okay, 40 plus 140 will give me 180 degrees. Okay, now that is the measurement of AFC. AFC is 40 plus 50, okay, which is 90 degrees. So the measurement of AFC is 90 degrees. And then the measure of CFD is also 90 degrees, which makes the 180, okay, from the straight angle, okay. So now we need AFB. We already got that. That's 40, okay. AFB is 40, okay. And AFC is 90 degrees. Let's take a look at the measure of DFE and AFE. So I have DFE. DFE is this angle right here, and AFE. AFE, and then this angle right here, okay? So I know that DFE, okay, is equal to AFB right here. They are vertical angles, so that means they're congruent. So that's 40 degrees, okay? And then I know that these two angles, DFE and AFE, okay, these two angles here, they form a linear pair, okay? Because they form a linear pair, they form a straight angle, right? I just have to do 180 minus 40 degrees, and I get 140, okay? So that means that the angle AFE is 140 degrees. Proof, and we're starting with the fact that if two angles are congruent, then their complements are congruent as well, okay? So the first statement here is that angle ABC is congruent to angle DEF. That is given to us. Then the measure of the supplement of angle ABC is equal to 180 degrees minus the measure of angle ABC. That's the definition of supplement of an angle. Okay? Definition of the supplement of an angle. as we looked at your turn above. Then the measure of the supplement of angle DEF is also equal to 180 minus the measure of angle DEF. Okay, again, definition of supplement of an angle. Then the measurement of ABC is equal to the measurement of DEF. Okay, so if the two angles are congruent, right, their measurements are equal. Okay, if two angles are congruent, that means their measurements are equal. Notice over here that angle ABC and angle DEF are congruent. Okay, so that means the measurements are equal. Then the measures of the supplement of the angle DEF is equal to 180 minus the measurement of angle ABC. All I did here is I substituted, right? I used this line here and I substituted measure of angle DEF for the measure of angle ABC, right? Because they are congruent, so I can switch them around. And that's the substitution property of equality. Now the measure of the supplement of angle ABC is equal to the measure of the supplement of angle DEF. Okay, that's the substitution property of equality. Okay, that we use here to for this statement. Now the supplement of angle ABC is congruent to the supplement of angle DEF. And if the measures of the supplements of two angles are equal, then supplements of the angles are congruent. And that was our statement above that we were trying to prove that their complements are congruent. Okay.